Almost done. So, we're now, guys, we're going to take the volumes, and we're going to go between curves, but now what we're going to be doing is rotating it. So, volumes of revolutions. Before we do that, let's go ahead and do the bell work. So, go ahead. So, if I need to find the area between these two curves, what would that look like? I'm going to integrate between what? 0 and pi over 2. Yep. And I need to know which one comes first. So probably the easiest would be to like put something in between to double check, but yeah, it is sine, right? But let's say I use 1. 1 is between 0 and pi over 2, right?
When you say it comes first, it's
That comes on the top.
on the top.
Yeah. So sine, right? Versus, so 1 cubed minus 2 is going to be -1. Sine of 1 is definitely not negative. So the sine should be on the top. Now, technically speaking, I should double check that they don't ever equal each other on this interval. Okay? But they
What
don't.
happens there? Oh,
Then we'd have to switch it. But in this particular case, that is not what's going on. And then I can just, well, I guess actually this one we can do by hand. We don't need to do it. I was going to do it on the calculator, but we don't need to. So this would be sine of x minus x cubed plus 2x dx. And so then we're going to get negative cosine of x.
Wouldn't the first one also have the x?
Well, because I put them all together, so there's just 1 dx on the whole equation.
No, but like for the first one.
Like where you wrote gx minus f.
Yes, I see what you mean. Yes, it should have had dx. You're absolutely correct. And then I'm going to evaluate this thing from pi over 2 to 0. It's going to be a gross decimal. Sine of pi over 2 is easy. That's 0. Minus pi over 2 to the power of 4 over 4 plus pi over 2 squared minus cosine of 0 is 1. And then the rest of it's just going to be minus 0. Minus 0 plus 0. So, and then, yeah, I'm still going to have to kind of put that in my calculator, I guess, because that's kind of gross. What's that going to be? Negative pi to the power of 4 over 2, 4, 8, 16 times 4, 64 plus pi squared over 2, 4 plus 1. Or, let's figure out what the heck that is on our calculator. You'd leave your, yeah, if this is a non-calculator problem, you'd leave your answer like that. Otherwise, you should probably simplify it. And we get 1.945.
Why is it below 64?
What's 2 to the power of 4? 2, 4, 8, 16, and then 16 times 4. Right?
Okay. But why did you put 4 in the other?
Here? Because 2 to the power of 2 is 4. Right? You have to do the whole fraction has to be squared. The whole fraction has to be the power of 4. So the pi over 2 has to get to the power of 4, and then you divide it by 4.
Those decimals. Es que paréntesis, the paréntesis make it weird.
Why?
Because you think that you know multiplying by the
No, it's the opposite. If I didn't have the parentheses there, it would only be on the numerator. I have to put the parentheses to show that it's on everything. Because if I just did this, that's totally different. Right? I have to show that it's the entire thing that I'm squaring. Okay, this is the same as pi over 4, 2 to the power of 4.
No, I didn't see you.
Okay. All right. Anyway, so we're good. Look at that shape.
What
So, solid revolution is formed when we've got a flat two-dimensional shape and we rotate it about an axis. So considering the region on the left here, where we just have this part of a quadratic, when the region is rotated about the x-axis, it's going to make the solid that you can see in colors on the right. Object of the lesson is to learn how we do that. It's not as hard as it seems, I promise, okay? So, imagine slicing the image into individual discs of height 1. So in other words, like going over here and being like, okay, 1, 1, 1, 1, 1, etc., 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 okay? Then here, we're going to rotate it about the line y equals 0, okay? That's important because the volume of one of these discs here is going to be pi r squared h, okay? Where in this thing, the radius is whatever's changing, right? And our height is just 1 because we did them in height 1. So it's just pi equals vr squared. So then, if that's the case, to sum up all of those disks, we could integrate from a to b, right, of pi, why pi? Because it becomes a circle, we're rotating it. And then here, to get our radius, what is the distance from the actual graph to the x-axis, is going to be f of x, or function, minus the axis of rotation. The axis of rotation is right here, right? It's that line. Do I have to rotate it around that line? No. I could rotate it around something else, in which case I change this axis of rotation. And of course, this is the radius, which is why it is squared. No. The f of x minus the axis of rotation is the radius. Okay? Now, if we have a constant like pi, I can, of course, just take that constant and put it outside. It doesn't make a difference. Leave it inside, put it outside, changes nothing. Okay? Because it's a circle. Right? If these things here, it's going to form like a disc that looks like that, right? Okay? And then what we're doing is we're saying the volume of that disc is pi r squared. Because the h, this distance here, we made it 1.
So why not pi r squared?
That is what we just did. Pi r squared.
Okay.
Right? So the f of x minus the axis of rotation tells us what is the radius of that disc. It has to be a function because it's different. Here, my radius is less than my radius here. So I have to have it as a function because it needs to change. Benji.
Why, if you said that pi is a constant, but differentiates from
Well, that's why we can put it up front. It doesn't matter where the pi is because it's just, we're going to multiply our answer by pi.
So if they ask you to find both of those in like a question, you just do that.
Well, they're never going to. They're just going to say find the volume of the solid.
So you just do it like that. No?
Yeah. Yep.
The h, what is the equation? Why is it the same?
Well, the only difference is I moved the pi outside because
No.
I don't need it there.
Oh, where it says b equals pi.
Because what is h?
1.
Yeah. So we can ignore it because it's 1. All right. Notice that the axis of rotation is the x-axis and the bottom function of the region is also the x-axis. Imagine for a moment that the solid would look like if the axis of rotation were still the x-axis, but now the bottom function is something else. This line y equals c, which you can see here, right? Y equals c. The solid would look similar, except that there's going to be like a hole through the middle of it, right? Because if you imagine this thing, it's going to look something like that, and there's literally, like, this is an open hole. Does that make sense? Okay. To find the volume of this solid, we need to find the volume of the whole solid that we found previously, and then subtract the solid that makes the cylinder. So that would mean that we'd have to have pi r squared, that's the outer function, so that's the whole thing that we already did, minus this part is like the hole. I don't know why I said hole with a W. This is the hole in the middle, okay? And in total, that's going to give us the area of like this thing. But of course, imagine it 3D, so it's, it's just, I'm doing a cross section so you can understand that there's a hole in the middle. Okay? So, outer function is defined by the function that is further. So this one is further from the axis of rotation. this one here is going to be closer. And you'll remember that yesterday I had said that that's eventually what we'll do, right? So far we've done top minus bottom. Well, this is still top minus bottom, but if we end up rotating it differently, then it might change. If the axis of rotation is no longer the x-axis, maybe it's the y-axis or something, it can change. So we have to go the further one minus the closer one always. Okay. So let's write out like what that would look like in our particular case here. So this would be the volume is equal to pi, the integral from a to b, because we don't have numbers for them yet. Okay. And this would be f of x is our function, that red line, minus the axis of rotation, which is 0, all squared, minus the inner function, which is just going to be c, whatever we made c, minus the axis of rotation 0, squared. And then that whole thing dx. Right? So this gives us the entire solid. This gives us the piece that we remove.
Why is it 0?
Because it's rotated around x equals 0. So the axis of rotation is 0. If the axis of rotation was y equals -1, I would have to go minus -1.
So like the radius of the hole, like the middle of the hole is 0. That's what it's saying.
In this case, yes. But the middle doesn't have to be 0 if it's
No,
if we're rotating it around something else.
but they do mention that.
Yes. So that's why for now it's easy. We always start with it easier and we're going to build it up. So our axis of rotation is going to be 0 because that's much easier for us to understand. All right. So if the axis of rotation is parallel to the x-axis, then the integrand needs to be in terms of x, and the limits of integration need to be x values. Okay? So if we consider this function over here, y equals x squared, and y equals x plus 2, find the volume of the solid formed when the region is rotated about the x-axis. So if we're going to rotate it about the x-axis, that means that the volume is, what is that top or further function so far? Is it the line or the quadratic? It's the line. So we're going to integrate, and our intersections here are at -1 and 2. So we're going to integrate from -1 to 2 of x plus 2 minus 0. I don't technically need to write that, but I will, right? Because our axis of rotation is the x-axis, minus the bottom function, which is going to be x squared minus 0. It's not c this time because this last time it was c because it was a solid line, right? And the equation for that line is just a number. Whereas this time it's a curve again. So that's why we have to do the x squared. And that's all squared and then dx. Okay? Do I need to worry about those zeros then?
So when it's like depending on the line that it's moving, it changes like the
Of course. Yeah, like if we think about this one is going to end up looking like something like this. Like our solid will look something like that then is rotated. So there's no hole in the middle. There's like a little bit of a like scoop out here and a little scoop there.
But
Right?
wait, Mr. Bass, why is it that weird shape?
Oh, I missed the pi. Hang on. Oops. What?
Why is it that weird shape?
Because that's just the shape that it is. Imagine this
Okay,
shape
okay,
is
yeah,
being
yeah.
rotated around the
Yeah,
x-axis.
like reflected.
All right, so it's going to be the integral from -1 to 2. We can simplify this. This is really just x plus 2, and it's really x plus 2 squared. And since you're all paid lots of attention last year in pre-calc, you know that x plus 2 squared is x squared plus 2 times the middle term, so 4x, plus the last term squared. Because you all paid lots of attention last year.
No, that's not true.
Yeah, and then x squared squared is x to the 4th. Now, can I integrate that easily?
Yeah.
Absolutely. So this is going to be pi x cubed over 3 plus 2x squared plus 4x minus x to the 5th over 5. I guess technically plus c, but I'm not going to bother with the plus c because we have bounds. And anytime we have bounds, remember the constant just disappears. And then I just need to plug all that in, right? So it's going to be pi times, I put in 2 for all these things. 2 cubed is 8, so 8 thirds, plus 2, 4 times 2. Go for it. Okay. And then we get 4 times 2, which is also 8, minus 2 to the power of 5. 2, 4, 8, 16, 32. Over 5. Minus, and actually this pi is around everything. Negative 1 cubed is negative 1/3. Negative 1 squared is positive, so that's going to be plus 2, minus 4, plus 1/5. And then I just got to work all that out.
Oh, okay, yeah.
Right? So let's see. I know, right? You're welcome. Yeah, this one probably should have had a little more space.
A little one.
Yeah, probably. Let's see, that's going to be 16. This is negative 2, so 16 plus 2 is going to give me 18. 8/3 minus, or negative 1/3, so 8/3 plus 1/3 is 9/3, which is 3. Negative 32 minus another one is going to be minus 33/5. That's going to be pi times 21 minus 33/5, which is going to be, what's 21 times 5? 105? So we got 105 over 5 minus 32, or 33, sorry, over 5, all times pi. 72/5 pi. That's our volume. I know, I should have given you a lot more room. My bad.
Mr. Brad, do we get a break here? Not here, but like this lesson.
We'll see.
Yeah.
The lesson is very short.
Is it?
Yeah, it's just one page.
No, this should be another page now.
No, it's this,
This
page
and
and
Oh, yeah, yeah.
fantastic.
All right, find the volume of the region that is rotated about the line y equals 4.
Can we do that by ourselves?
No, I don't think you can yet. Let's do a different color. So I got to go through this line. Right? So now I'm going to rotate it about this line, y equals 4. If I do that, it's going to totally change my shape, right? I'm basically going to make this weird looking bowl. It's going to go like something like that, but then it's rotated, so it's literally just this big bowl that's hollowed out with like a cone in the middle, right? When we rotate it around this line. So now it's going to be totally different when we write this, right? Because now, instead of our axis of rotation being 0, it's actually going to be something. So it's going to be pi times the integral, same 2 points of intersection, negative 1 and 2. But now, first of all, what is the function that is further away from that line, that axis of rotation? Yeah, it's the quadratic this time. So we got to switch the order of them. So this time it's going to be x squared minus the axis of rotation, which is 4 squared. Okay. Minus the inner function, which is our x plus 2. Minus the axis of rotation squared dx. Yeah? Now, what is this really? Instead of x plus 2 minus 4, what is that? Simplify. X minus 2. Then we're going to simplify it that way, Benji. Yes. Okay, so now to continue, this is going to be the integral of negative 1 to 2 times pi. X squared minus 4 all squared. Don't panic just because it's a squared. It's still the same thing. It's a perfect square. So it'll be x to the power of 4 minus 2 times the middle term. So 8x squared times 2 times the final term. So plus 16. Minus, now it's just x minus 2 squared. So x squared minus 4x plus 4 dx. Can I combine anything? Yes. Right? So I've got x to the power of 4. Negative 8x squared minus x squared is negative 9x squared. minus negative 4x is plus 4x. And then 16 minus 4 is 12.
Why 9x squared?
Because negative 8x squared minus x squared is negative 9, right? We're just combining the, so all I did here is combine the like terms. So I had this one with this one, and then I had my 16 with the minus 4. Now can I integrate that thing?
Yes.
Yeah. So that's just going to be x to the 5th over 5. Minus 9x cubed over 3 is the same as 3x cubed. 4x squared over 2 is the same as 2x squared. Plus 12x. Don't need the c because I'm going to evaluate this from 2 to negative 1. Amazing. What's wrong, Matthias? We broke you? A lot of things wrong with you? I mean, that's true. Preach it.
In what cases do you get C and in what cases do you not?
You always get a c. Why do I not include c when we're doing bounded integrals?
Because we already have it.
Because what?
They will cancel.
They'll cancel. Because I'm literally going to get, like, at the end of this, it's going to be like plus, whatever. Let's say it's 9. It'll be plus 9, and then when I subtract this one, it'll be minus 9. So the c value always goes away. So it is there. It's just when you're evaluating, you don't need to write it. But if I write just the equation unevaluated, then I need to put plus c. Okay? All right. Then I'm going to plug in 2. So this is going to be 2 to the power 5 was 32. So 32 fifths minus 24 plus 8 plus 24 minus negative 1 is going to be negative 1/5 plus 3 plus 2 minus 12.
Sir,
Yep.
I know you already explained it a couple of times, but I still don't understand why the order changed. Like why first we did the parabola minus the linear one, and then we
Okay.
did,
For the blue one, our axis of rotation was here,
yes.
the x-axis. Which function is further away? The line.
What do you mean further away?
Well, like pick any point. If I pick here, which one of these two functions is further? It's this one, right? So we have to use that one. But now that this is our axis of rotation, the further away one is the quadratic, and the line is closer.
And we choose the one further away because if not, you would give us like the same answer, but the opposite sign.
Yeah, it doesn't work. Yeah. Okay, so now let's continue combining this. 32 fifths minus negative 1/5. That's the same as 33 fifths. Let's see if we can do all the numbers together. These just straight up cancel. So this is going to be 8. This side is 3 plus 2 is 5 minus 12 is negative 7. So 8 minus negative 7 is the same as plus 15. We can rewrite 15 as being 75 over 5, which means that I'm going to get, what is that going to be, 108? 108 pi over 5. Does that make sense? Do we feel good about that?
Yeah, but if you have a calculator for this question, will you have to plug this in and see?
If you had a calculator, yes, you could use it. If you don't have a calculator, I would recommend you leave your answer in exact terms like that.
Yeah.
Because not only is it easier, they'll usually ask you to leave it in exact terms. Right? I usually will.
Can we try doing this one by our...
The next one?
Yeah, it's the same thing, but with 2. No.
It is the same thing except with negative 2, so sure. I will pause the video, you guys give it a try. We take it back. No, they do want to do it, but what we're going to do is at least draw it out first. So let's draw out that our line of rotation this time is down here at negative 2, which means, this is where it's going to get kind of awkward. I can't even really draw it, but it would be like the shape is going to be over here. I don't want to cut off everything. And so you're actually just going to get like a disc, like kind of like a donut, right? Like there's everything in the middle here is empty for this one. Does that make sense? And then of course this is rotated to make it into like a disc.
It's like a hole.
Yeah. Yep. All right, so that's what it's going to look like. So now, go ahead. Do you guys want me to just do it without saying it?
Yeah.
Okay, so you guys do it. I'm not going to talk you through it, so you just try and do it. If you're on the video, just pause it. Give it a try.
Mister,
Minus negative 2. The question there, guys, was just that this was, shouldn't it be minus 2? And it is, except that it's minus negative 2.
How much is left of this lesson? Like 1 question. And then you gotta do something.
And we're just simplifying. So that's really x plus 4, which is a perfect square, so the x squared plus 8x plus 16.
Sure, I haven't seen anybody selling anything. I wanted to buy something sweet and nobody's selling it.
I know, it's very sad.
Está fácil.
Está más lejos, yo la resto.
Then we can combine.
Exacto, ¿cuál es la que resta?
O sea, es la parábola de la línea.
No, pero ¿cuál es la correcta?
Es la línea.
Combine.
Mr. The one that is further away is the one that like
Mira,
subtracts.
todas son iguales, se subtractea igual.
O sea, la que
No,
está
the
lejos.
no, the further one is the first one.
Ah, so
Ma-
you subtract the one that's closest.
Yeah.
Me faltará Oxford de
no,
Science.
6x.
Okay. Y
No, because it's x squared here minus 4x squared, so negative 3x squared.
acá yo no sé cómo poner esos números ahí.
Bueno, entiendo cuando va primero.
Let's see, x plus 12. Now I can integrate.
Y porque como así cambian, pero es muy fácil.
Manuel, do not come in late and distract the class. Then we can evaluate it. Yeah, by the time the negatives will cancel.
Mister, what is that?
What is what?
1 over 5. Or what's in the second part?
Oh, it's just a positive. Because I had written negative, but it's actually positive. Because it'd be negative 1 to the 5th, which is negative 1, times negative 1 is positive 1.
But it's over 5. That's the point.
Yeah, it's over 5, yeah. Okay, these simplify down to negative 7, so it's plus 7. So then minus 1. 40 minus 1, so plus 39. Which means, oh, that's gross. 39 times 5. 200 minus 5, so plus 195. Then we combine those. 162 pi over 5. Nice. Once you guys are done, check, see if you got the same answer. All right, so I've had this question a couple times, so we'll quickly address it. So once we've integrated, we're effectively applying the fundamental theorem of calculus. So we have to evaluate it at 2, the bound that was on top, b, minus the evaluation at 1. So this here, that's the evaluation at 2, right? And then I have to subtract the evaluation of that function at negative 1, and then I simplify it to get my final answer. Does that make sense, everybody? Yeah, so that's why we have to do it twice. And then we combine them. And it's just the fundamental theorem, right? That's where we did like the integral from a to b of fx dx is equal to f of b minus f of a. And that's effectively what we're doing. Okay? Good?
Yeah.
Awesome.
sir.
Yeah.
So like at the beginning, you start with expanding that.
Yeah, so the question here was, we just had, they're asking, like, you expand it and then you integrate. I said, yes, because in AB, we don't learn how to integrate something like this. So we have to make it look like a polynomial or polynomial-like, air quotes, and then we can integrate it. Right? Because the only trick I've taught you guys is U sub. That's the only thing we do. Otherwise, it's considered calculator work. So you need to be able to either turn it into a polynomial-like looking function, meaning it can have negatives and fractions, but it should be a polynomial otherwise. Or it needs to be something that can be solved with a U substitution. Otherwise, it's your calculator. That's the only thing we do in AB. Okay? All right, what about if the axis of rotation is in the y-axis? So if you remember yesterday, that was what we had said in our bell work, right? Well, it could be the y-axis instead of the x-axis. That's what we're going to do. If we're doing that, all that really means, you guys, is that we need to kind of change our equations, because we want our equations to be written in the opposite form. So instead of them being y equals, I want them to be x equals. Well, this one's nice and easy. How would I get x equals? I just square both sides, and I'll get x equals y squared. This one here, I just move the 2. So x equals y plus 2. So those are the two functions I'm going to use, rather than the ones we're traditionally used to using, which are y equals. Because we're just going to do everything flipped 90 degrees. Okay? That's all we're doing. So now we're going to find the volume, and the region is rotated about the y-axis. So this time, I'm rotating it here, right? So I'm going to get something that looks like this, right? So it's that same shape we had before, but we're rotating it a different way, okay? Okay, so our volume, it's still a rotation, so we need pi. We're going to integrate between the intersections, but what are those intersections? Well, it's the y values this time. Now, in this particular case, I very purposely made a graph that is similar. So it's going to still be -1 and 2, but this time that's because those are the y values, not the x values. Oh my goodness, there we go. I won't write. Okay, so which function is further away from the y-axis? Well, the y plus 2, exactly. So I'm going to do y plus 2, technically minus 0, squared, minus the closer function, which is that y squared, technically minus 0, but I'm not going to bother writing minus 0, squared, dy. We okay with that? Yeah? All right. So then we just keep going and expand it so that we can do this. So this is going to become y squared plus 2, or 4y, sorry, my bad, plus 4, minus y to the power of 4 dy. And now, of course, I can integrate that. And so I'm going to get y cubed over 3 plus 2y squared plus 4y minus y to the 5th over 5. And I'm going to evaluate that from 2 to -1. All right. So then I just have to do that again where I'm plugging in those two values into everything. So it's going to be 8/3 plus 2, 4, 8 plus 8 minus 32 over 5. Now we subtract when we plug in -1, and I'm going to get -1/3 plus 2 minus 4 plus 1/5. Because there's -1 to the 5th is -1 times the negative in front means it's positive 1/5. All right. Then we just combine all those like terms. So 8/3 minus 1/3. Or no, where is it? Yeah, 8/3 minus -1/3. That's like 8/3 plus 1/3. That's 9/3. That's 3. 8 plus 8 is 16. Over here, it's 2 minus 4, so -2. So 16 minus -2, 18. And then 32/5 minus 1/5. Well, that's -33/5. That's going to give me 21 minus 33/5, which means that that's the same as 105 over 5 minus 33 over 5, which gives us 72 pi fifths. So, same thing as we got last time, it's just that now our graphs were different because we tilted them rather than them being vertical. All right. So next one, you guessed it, we're going to this time rotate it around a different line. So x equals 4. Now, what do you anticipate the answer should be if we're doing it this way? The same as the last one because we're manipulating it so that it's the same. We're just showing you we can do it in more than one way, right? If the graph was different, would the answer be the same? No, right? It's only the same because we are putting that rotation right at this little point here again. Okay. Before I go down, which one is now further away from that axis of rotation? Yes, exactly, the y squared graph. So this time my volume is going to be equal to pi negative 1 to 2, but we're going to do the y squared first. So y squared, and this time it's not minus 0, but minus 4, our axis of rotation, squared, minus y, was it y plus 2? I forget. Yes, y plus 2. So y plus 2 minus 4 for the axis of rotation, squared, and then dy. So this y plus 2 minus 4, that's really the same thing as just y minus 2, which will make it easier for us to do a perfect square. So now we're going to integrate pi times the integral from negative 1 to 2, and then we just expand our perfect squares. So y to the 4th minus 8y squared plus 16 minus y squared minus 4y plus 4. And I'm just expanding those two perfect squares. That's all I did so far. Then I'm going to combine my like terms. There's only one y to the 4th, so that goes there. I've got 8y squared, or negative 8y squared minus y squared. That's negative 9y squared. And 16 minus 4 is 12. So now can I integrate that I've got everything kind of combined? Absolutely. And this is going to be, once again, y to the 5th over 5 minus 9y cubed over 3 is the same as 3y cubed. And then 12x, oops, I wrote x. Should have been y, my bad. Because we're doing it this time dy, right? So we got to use y as our variable. And we evaluate it from 2 to negative 1. Now we do that evaluation. It's the same as it's been, 32 over 5 minus 248 times 3, 24, plus 24. Now we subtract when y is negative 1. So negative 1/5 plus 3 minus 12. And then I just combine everything. These 24s will cancel entirely. And what is 32/5 minus negative 1/5? Or in other words, 32/5 plus a fifth. 33/5. And then we've just got 3 minus 12 is negative 9, so plus 9. I feel like we did something wrong. Hang on. Because it should have been the same as last time. And last time it was 15, wasn't it? Hang on. I missed this. I missed this one. Yeah, if you look here, I missed this one. We should have plus 4y mixed in there. Yeah, it's like there's something missing. So this here, we should have had 4 times 2. So that would be plus 8. And over here, we should have had another minus 4. Okay, so that's better. So now we've got an 8 out here, and then over here we got 3. So this is, oh, hang on. No, that's still not working. What the heck did I do?
It should be plus 1. That would be plus
15. Because once I integrated, it's no longer 4y. That's why. This is what happens when I make a mistake and have to go back and try to fix it. So the 4y integrated should have been plus 2y squared, right? And then when I plug it in, it's still going to be plus 8 on this side, because it's 2, 4 times 2. But then on this side, when I plug in negative 1, that's going to be plus 2. There we go. Okay. So now on here, we're going to get negative 7. And so we get 8 minus negative 7, which is 15. Oof, good thing we were doing the same problem. I could see. But yeah, that's I missed that negative 4y there. Okay. Everyone okay? Everyone understand where the mistake was? Yeah? All right. We'll take your silence as yes. Or the couple people that said yes. Then I just need to combine these again. So that's 33 fifths. Plus times 5 is 75 fifths. And so our volume will be 108 over 5 pi. There we go. Last one. Is this last one going to be the same or different than when we did it last time? Different. Why?
Y is x equals 7.
Yes, because last time we did, I think, like it equals 6, right? Negative 2. And this time we're going to do it at 7. So this one will be different. We're going to have our line way over here, which means that this thing's going to be off the page, right? But the way we solve it doesn't change. So it's still going to be from negative 1 to 2 times pi. Now this time when we look at it, which function's further away? Still the y squared, right? So it's still going to be y squared, but instead of minus 4, this time it's minus 7. Then we put our closer function, which is y plus 2 minus 7. We're going to square that too. dy. So then we just expand them like we've been doing. So that gives me y to the 4th minus 14y squared plus 49. Yeah, I should. You're right. This is really y minus 5. Yeah, good point. And then we can square that one easier. So that would be y squared minus 10y plus 25. Good. Oops, that should have been on the outside. Then we combine those like terms. So y to the 4th is by itself. We've got 14y squared minus y squared, which is going to be minus 15y squared. And then we got minus negative 10y, so that's plus 10y. And then 49 minus 25 will give me plus 24. Then we're going to integrate. So once we integrate, y to the 5 over 5. 15y cubed over 3 minus 5y cubed. 10y squared over 2, 5y squared, plus 24y. Evaluated from 2 to negative 1. So now I'm just going to plug in 2 and negative 1. So 32 fifths. 2 cubed is 8 times 5 is, or negative 5 is minus 40. 2 squared is 4 plus, or times 5 is 20 plus 48. Then I subtract it all when it's negative 1, so negative 1/5. Plus 5 minus 24. So those fifths are the same thing again, 33 fifths. Oops, forgot the pi. All right, negative 40 plus 20 is negative 20 plus 48 is going to be 28. And on this side, we got 10 minus 24 is negative 14. Minus negative 14 is plus 14. So I get 33 fifths plus 42. Put them into a common denominator. And I will get 210 over 5, which gives me 243 pi over 5 for my volume. Did it.